Hi guys, today we'll be learning about kinematics and dynamics for the PH1001. First, we'll be learning about the kinematics, which is the fundamentals that we'll need for most of the questions in PH1001. So, first thing first, we have to understand that in kinematics there's only two possible kind of questions, which is the first one is the constant speed movement. So with the constant speed or constant velocity, we just have that v equals to uh, the displacement over time. So this is all you need. But sometimes we need some basic math for the projection and stuff. And the next one is that we have constant acceleration, which is for this constant acceleration materials, we have three formulas that are important to memorize. So the first thing is that A equals to delta V over time. The delta V is the difference in the initial and final speed, initial and final velocity, or we can also write this down as V equals to the initial velocity added by the acceleration times the time, and we also have that the displacement is equals to the initial speed times the time added by half of at squared. And then we also have that v squared equals to initial velocity squared added by 2 times the acceleration times the displacement. So maybe I have to write down that here v is velocity, s is the displacement, t is time. Same here, but v here is the final speed, final velocity, but the v naught is the initial velocity. And I guess that's all you need for the kinematics. But most of the time you have to understand the vector and projection and stuff. Also that you have to get the basics of math. So I'll explain a little bit here. Basic math stuff to know. So first thing first, you have to understand a little bit of vector, which is it's just that you have to understand that AB equals to A, for example, B plus BB. It's just that you have to understand that this is the final, this is the initial, and this is the final. In the end, it has to come back from initial to final again, regardless of what is the things between them. You can have many different things. For example, if we just change it to A B plus PO plus OB, it just has to follow the same rule, initial here and final here, but it has to propagate through a correct order, which is this is from P back to P, and this is O back to O. And that's all you need. for the vector. The thing is that this vector rule has to be um, has to be followed, or has to be consistent in your equation of motion. So equation of motion here including acceleration, speed, or velocity, and displacement. Okay, that's the factorial. We will see how we're going to work on this. And next up is that usually we'll do have some projection, for vector projection or just map projection. The simple stuff to deal with sin, cos, tangent. So if you have this, you have to be able to project this. If this is the theta and this is the phi, you have to be able to know that this is phi cos theta and this is phi sine theta. Thus, this one also equals with the same height, right? It has to be phi sine theta. And any geometric with other geometric knowledge, geometric and trigonometric knowledge, which we will discuss later on because your ability to understand all of these things will grow throughout the courses lah. Okay, I mean throughout this PH1011 course because it follows the same logic. And last thing you have to understand that a little bit of calculus, So you have to understand the basic integration and differentiation, which you would have. Wait, I think most of the time students take this course at the same time they're taking MH 1810, which is a little bit weird because they're supposed to be able to understand the calculus already. But yeah, whatever. So um, so the thing is that the first simple thing is that you have to know that the connection between kinematics can be correlated by calculus, which is if you have A, V, and S, you can um, you can integrate A to V and integrate V to S. But for the order in reverse, it has to be differentiated. Okay. So we can write this down as, so differentiation is that A equals to dv over dt. Oh, the integration and the integration here is in terms of time. Okay. So for example, A is the differentiation of v over dt. This is differentiation of v with time, with respect to time, and v equals to the integration of a dt. Yeah, this is the basic knowledge math. We'll discuss this a little bit later on the physics itself. But yeah, and then you have to also understand that if you have a graph, for example, like this, and this is v time, and we have any kind of graph, we can so this is v with time. So if you integrate v over time from time 1 from the T1 to T2, for example, if you have this T1, this is T2, so the integration of phi dt from T1 to T2 equals to the distance. The distance here is the distance from T1 to T2, the displacement. So if you have a point and then it moves with a certain speed, which is represented by this graph, um, it will move this much displacement um, with this formula. But if you are given a graph, this formula can be represented as the area under this curve. This is basic math stuff also. So this is equals to this. Okay. So yeah, I think that's all you need for the basic materials. We'll just jump right into the questions. Wait, I don't think we can jump into the question, but because first we have to talk about things about parabolic motion. So this parabolic motion is just part of kinematics, but added with factor and stuff. But it's just often come out in the quizzes and on the final exams. So if you just want to pass the courses, you can just skip all of the understanding and then just jump into the parabolic motion. So how do you get parabolic motion is that um, let's say we have this coordinate x and y, and a thing is projected, is just thrown at a initial velocity v naught with an angle theta, and we have a gravitation acceleration downward. So obviously, um, this particle will follow this path, this parabolic path, right? So most of the time, you'll get questions like what time that this particle hits something here, or what times it reach its maximum height and stuff like that. So there's a general equation for this kind of parabolic motion, which is represented by both axes. So that's why we have to project here. We have to project v naught, or the motion, into two axes, which is the horizontal and vertical axis. So here, for horizontal axis, there is no acceleration, thus there is it's just like a constant speed, constant velocity motion. In this constant velocity motion, you have that Vx, which if you project this V naught, this is the V naught, and this is the theta. So this is the V naught sin theta, and this is V naught cos theta. So equals to V naught cos theta equals to the distance divided by time, but the distance here is x over time. So we get that x equals to V naught cos theta times time. So this is the x-axis, the horizontal axis, and for the vertical axis, we have Vy, which is V sine theta. But for the vertical axis, we have the acceleration downwards, gravity acceleration downwards, which is G A equals to minus G. Why minus? Because it's downwards. And our Y is pointing upwards. Okay. And the G here is equals to 9.8 meter per second squared. Depending on what G they tell you in the question. Usually they'll give you 9.8, but sometimes they give you 9.81, or sometimes they even give you 10. So yeah. Okay, so basically we'll just follow the same equation that I told you before for the constant acceleration, which is this one. So you have that. This is the Vy naught, and this is the Vx naught. The Vx and Vx naught is equal throughout the motion, but you will have Vy equals to Vy naught minus plus AP. So Vy naught, Vy is the y acceleration, the vertical acceleration. Vy naught is v naught sine theta, and the acceleration is minus g, so it's minus gt. So the other equation follows that y, so we have the equation s equals to v naught times plus half of acceleration times squared, so it's y equals to v naught sine theta times minus half of gt squared. Okay, and then the last equations will be vy squared equals to v naught squared sine squared theta minus 2gy. Yeah, so yeah, that's all for the parabolic motion. We'll try to do the questions now. So yeah, let's just start it. So this is the questions from the final examination on year 2020. So it's um, final 71, and it's number 4b. So this is the question. A ball is thrown horizontally from the top of the cliff. So this is a cliff, okay, and it's thrown horizontally with a speed u. Um, it's at any moment its direction of the motion makes an angle theta with the horizontal. Derive an expression of theta as a function of time as the ball follows the projectile's path. So this is the path given, and at any time here, it will create an angle theta with the horizontal here. So you have to find this theta. That's what they are asking on. So how to answer this kind of problem? So this kind of questions asking you the theta. But what is the theta about? The theta, is it about the distance? Is it about the speed or the acceleration? So here's the note that you have to remember, that angle that a motion makes is always it's always about velocity. Okay, so yeah, that's the key thing that you have to remember. So we just find the velocity at any time here. So the first thing you have to do is that you understand that in this kind of questions we have the downward acceleration, which is g, okay, but the because there's no acceleration in horizontal direction, so for horizontal the vx is always equals to the initial horizontal velocity, which is u, and the vertical one, it's vy equals to vy naught added by acceleration added the times time. Okay, So the initial acceleration is 0, the acceleration is minus g, and the time is t. So it's minus gt. So the vertical acceleration is equals to gt, but it's minus, which is going downward, which is makes a lot of sense because it's going because the horizontal velocity, yeah, it's u lah, but this vertical velocity is gt, and because it's going downward, we have the minus symbols here. So yeah, so now we already know that the theta here, this part is u and this part is gt. So if this is the right triangle, so if we just move this gt here, or yeah, this line is gt and this line is u. So we have the tan theta equals to gt over u. So the theta of as a function of time equals the inverse of tangent of gt added by u. Or this is the answer. This is how you represent the answer. Or if you want to make it on your own way, sometimes people use as arctangent of GTU over U. Yeah, that's all for this kind of question. It's pretty simple. We move on to the next questions. Okay, we'll continue with the questions of the quiz one. Quiz one of 2021. Um, so the question is, a ball is launched with a so ball is launched with a velocity 2 meter per second from the bottom of an inclined plane as shown in the figure 1. So I'll just draw you guys the figure here first. This is the y, this is the x. So wait, I'll show you guys the picture first because it's important, because I want to teach you guys something. Yeah. Here. Oh, wow. To stop share screen. Here. Okay, you guys can see this, right? Okay. So we can see the okay. So a ball is launched with this velocity, and from the bottom of an inclined plane, shown in figure 1, the bottom of inclined plane is xy plane, yeah, whatever. So we can see that the theta here is 45 degree and the phi here is 20 degree. So this is my tips so that you guys don't get confused for a lot of things in, it's not only for physics, but it's for a lot of your modules, everything related to angles or anything. I will advise you to not sketch angle in 45 degree. So even if the angle is theta here is 45, so the thing is that this may not apply to most of the courses, but if the courses is relating about physics and it doesn't require you to do in scale drawing, I will always advise you to not draw it draw an angle or any angle close to 45 degree. Why? Okay, so I'll show you why later on. So let's stop sharing here. Get back to this screen. So um, the easiest thing is that to not draw the angle in 45 degrees. So because if you draw this angle 45 degree like angle, so it's close to 45 degree. So this is the theta, right? The problem that you have is that um, it's hard for you to track which theta is theta. So actually for 45 degree, it's not actually a problem. If the theta is actually 45 degree, it doesn't really matter. If you want to track this angle, okay, so this angle is it's theta, but this angle looks like theta also, because this is almost like the angles. So if even if you have an angle that is close to 45, for example, it's 48, so you draw it like this, it's very hard for you to track because it's theta. So this is if this is 48, this is also 48, and this has to be 90 minus 48, which is 42. But this angle looks very similar to this angle, so it's very hard for you to track. So the easiest thing to do here is to make every angle, to create every angle in uh, very small or very large scale. It's just you have to make it. You don't have to, but I will advise you to make it uh, far from 45 degree. For example, I'll create the angle like this. It's very sharp angle, so it's easy for you to track. This is the theta here, especially in PH101, because in PH101 you will find a lot of problems with no given angle. So the angle you just have your answer has to be in terms of theta or phi or anything. So please don't draw the theta in 45 degree like angle because it's very hard for you to track. Because for this time, right, if you have the 90 degree here, it's very easy for you to track that. Okay, this is theta, but this is not theta. This is obviously bigger than theta. But this one is very light. And if you want to track this angle, oh, this is obviously theta because it's small, huh? It's small, right? Okay, that's just an advice. That's an advice for me. And then we'll continue on this question. So the question is that a particle is launched with an angle phi with a velocity v. Um, so the question asks you calculate the coordinates x and y where the ball hits the incline. So there is two. There is actually okay, for these questions I'll give you two approaches. So the first approach is that we're using the regular parabolic motion. So the regular parabolic motion, you see in regular parabolic motion that the angle is always with respect to the ground. Okay, so for this motion, the angle with respect to the ground is phi added by theta. So everything here everything in this equation just replace it by the theta here, just replace it by phi plus theta. Okay, got it right? So x equals to phi naught. Phi naught here is v itself. It's given v, which is 2 meter per second. Okay, I'll write down the theta equals to 45 degree and phi equals to 20 degree. Okay, the x is phi cos phi added by theta times, and the y here equals to v naught sine theta v sin phi theta times gt squared. And that's it. All right. Um, I mean, we still have these three equations, but most of the time you only need to write down these two. I mean, these two is the most used in parabolic motion. So from this thing, we can get that t is x over v cos phi added by theta, and then we just plug in these times to the second equation. So x equals to v sin phi added by theta x over v cos phi added by theta minus half of gt. Gt is also substituted by v cos phi added by theta its squared. So y equals to x tan phi added by theta minus gx squared over 2v squared cos phi added by theta. Okay, so and then this is the y as a function of x. This equation is a y as a function of x. So this is the easy thing to do in parabolic motion, is that you can write y in a function of x by only substituting as this t is always equals to x over phi cos theta, and then you just plug in these times to this y equation, and you get y as a function of x. And why is this important? Because if you have this y as a function of x, you'll get this graph y as a function of x, and only by looking at the math, when it hits the plane, when it hits the platform, it's like um, it is an intersection point between this this y as a function of x and this function and this linear function. So if the platform that they hit is not a plane, for example, if it's a ball like this, you'll just try to find the intercept between this ball and our regular motion, our our y as a function of x. You'll just find the intersection, and that's very easy. Why? Especially for this plane, you have that, okay, because this is y and this is x, it's always going to be like that. If this is the x and this will be the y, you will always have that tan theta equals to y over x, which y equals to x tan theta. So because this is two equations, we can just plug it in right away. We'll just intercept both of them. So the y here equals to y here, and x here equals to x here, and you'll straight away get the y and the x. So just plug it in. X tan theta will just equate both of this y and this y. X tan theta equals to x tan phi plus theta negative g x squared over 2v squared cos phi plus theta. Oh wait, the cos is it's cos squared. Sorry guys. Yeah, because it's x squared and v and everything, it's squared. And then you can just find the answer. You can just find the solution for this equation. So the theta here is 45 degrees, so tan theta equals to tan 45, which is this, and this thing is just tan. It's 20 added by 45. I have to find my calculator. Yeah, tan 65, because it's 20 added by 45. Tan 65 is, oh, it's 2.145. Yeah, anything, it's not so much of a difference. Minus g is 9.81 over 2. V squared, the v is 2 squared, the cos 65 squared. Cos 65 is this squared is, okay, and it's gonna be 0.1786, okay, and it's x squared. So you have x minus 2.145, x times minus 1438. Why? Because we just if we move this into the left side, it's just x times the root 2 over 2 minus 2.145, which is this one, equals to minus over 8. Okay, we'll just try to find this number first. Wait, plug into my calculator. 8 6 6 x squared. So here the x can be 0 or the x can be 0.21. Okay, so these two answer is the intersection between our these two equations. The first one is is x equals to 0, which is redundant because it is the initial point. Of course, they both intersect. So this is the function, and yeah, they intercept here. But it's our initial position, which we don't want to find, but we need to find this, right? This is the one that we want, right? The one that we want, we have the x is 0.21, and then we just plug in this x to either one of these equation, we get the y. So y equals to x tan theta, the theta is 45, so 0.21 times tan 45 is 1, so the y is also 0.21. Yeah, that's it. That's the first approach. Okay, I don't think we need a second approach here. It's really easy to understand already. We'll just try to find another question so that you guys can be exposed with other kind of questions. Or should we just move on to the dynamics? I think we should move on to the dynamics here. We don't need any other questions. If you guys have any other questions, you guys can ask me, and then we'll discuss about it. We'll move on to the dynamics part. So in the dynamics part, we have um, we have mostly only two kind of questions, which is the dynamics in translational dynamics, which is it's only moving in translation, and we also have another one which is rotational dynamics, but it's on the other topics later on we'll discuss. But first one we have to be able to understand the translational dynamics first. So for the translational dynamics, it's just the Newton's method. Not Newton's method, sorry, Newton's law. It is the sum of F equals to M times A. So we can have different systems, but mostly we will have the static system, which it's static, which is it's not moving. So obviously the acceleration will be 0, the sigma f equals to 0. And it doesn't have to be that it's not moving, but it can also be moving with a constant speed, because the constant speed will have a 0 acceleration also. So the point is that the acceleration is 0, and then we have a moving system. For the moving system, we'll We'll talk about this later because it's basically the same as kinematics, but it will involve the forces. It will involve forces. It's same as kinematic, but involve. I mean, for the static system, it also involve forces, but it's the same. It's involve forces. So before we jump into the questions, uh, I would like to give you guys a little bit info about the possible forces that you guys can have. Possible forces. Okay, one, it's external forces, which is a forces, which is forces given by anything lah. By, for example, it's usually represented by an arrow, represented by an arrow. So the external forces is actually given by the question, given by the question. So, for example, if you have this block, so maybe the force will be like this. It's just like there's an F given to this block, yeah, whatever. It's just external forces. Next up, we'll have uh, forces, elastic force. So this elastic force is a force, yeah, which is elastic. It's usually from spring, usually from a spring. So yeah, and for the spring, the formula is equals to negative kx. The negative here is actually not important as long as you guys understand the direction. So if you if this is the spring, this is the regular length. It's the regular length of the spring, but the spring is contracted to this length. It will give a force. The force will be kx. It's supposed to be k delta x, but obviously it's okay. X is also okay. So x is the displacement. X is the x here is um the changes in spring length. So this is the x here. This is the relaxed condition. So this contracted one, right? Because it's contracted to the left, it will give the force to the right, which is equals to the k times x. K is a constant. A constant will always be given in the problem, or maybe the constant will be the thing that they are asking for. Okay, and if it's elongated by x, right? If the spring instead of contracted, it's elongated by x. It will have a force minus kx, or it's just kx to the direction of to the left because it's elongated to the right. The force is to the left. It's just the logic that the spring that you guys have. So here the x is here. Okay, because this is the relaxed position, it's elongated to this point, so it will have a changes x here, and because you pull this spring to the right, of course the spring will pull you back to the left, and because you push this spring to the left, it will push you back to the right. Yeah, that's the direction now. As long as you understand the direction, this minus, it's just not important. You just left this. You just imagine that there's no minus sign there. It's not important. And then there is there is uh, normal forces. The normal forces is just n. It's always okay. So it's always perpendicular to the plane. So if you have this plane, so the normal force is here. So if it's not a plane but it's a wall and you push something to the wall will give a normal force here, which is perpendicular to the wall as a plane. If you have a plane like this, it will also have this normal force here and everything. Even if you have a bowl, okay, a bowl, and you have a particle here, um, imagine the ball is in a perfect circular, yeah, in a perfect circular um, shape. You will have the normal force here. It's perpendicular to the plane that it touch. So the plane that it touch is here. It's perpendicular. Okay, that's it. That's the normal force. And the last force that I would like to talk about is the friction force. Friction force. So for the friction force, you will have two kind of frictions, which is the first one is the static friction. So for the static friction, if you uh, have a system here, um, this system will have a normal force with the ground. The static friction is the minimum friction, minimum friction for uh, for an object to be moved. Okay, or we can also say that it's a maximum capacity of friction to keep the object to keep an object remain stationary. Okay, so the thing is that static friction will have a formula F static less than or equals to the mu s times n. So for example, if we have the n here is equals to 5 Newton, maybe they have the weight of 5 Newton, so obviously in y direction it's static, it's not moving in y direction, so the n and y and the weight, sorry, and the weight has to be the same. So and if we have the static coefficient is 0.5, let's say, so here the Fs is less than 0.5 times 5, which is Fs is less than 2.5. Okay, because the Fs is less than 2.5, if we have a force, an external force of 2 Newton, so it is 2.5 Newton, Newton. If we have a 2 Newton force, this object will experience a static force, a static friction force of also 2 Newton to balance out the external force. Okay, so it's static. Okay, if we have a 2.5 Newton, it will also give out the same 2.5 Newton so that it balances out um, the horizontal force, so that it It remains stationary. It's not moving. Okay. But if it's, for example, 3 Newton, okay, this this ground cannot stand this 3 Newton, and it will move. The block will move instead. It will move to the right because the maximum here is this maximum static force. The capacity of the friction to keep the object remain stationary is only 2.5 Newton. Okay, so if you give 3, the maximum is only 2.5. It will, this friction will disappear and transfer. If this is a 3 Newton, this 2.5 will disappear and it will be transferred to the next friction force, which is the uh, kinetical friction force. Uh, yeah, it's kinetical. I don't know. Is it kinetical? It's not kinetical. What's the language here? I don't remember. Yeah, it's just another friction when it's moving. Is it kinetic? I don't know. Okay, it's just the other friction. I don't remember the term here. But yeah. So if this is 1 Newton, okay, they will give 1 Newton as well, so that it balance out. It doesn't move. But the capacity to keep uh, the object unmoved is 2.5. 2.5 is the maximum. That's the concept for the static friction. For the kinetical friction, if you have the yeah, if they already if the condition already satisfy this, if they already pass the static friction state. So the state here is that if 2.5 here is passed, the state is passed, you have a force that is bigger than the static friction. You will have the moving object with the kinetical friction, which is we say Fk. Fk is equals to the kinetical friction coefficient times the n. That's it. So yeah, so the kinetical friction is really simple. It's just there as long as the motion is, as long as the thing is moving. It's not the thing is moving. It's not the object that is moving, but there is a relative motion between surfaces. Between surfaces. So in these surfaces, uh, it will be moving. So this surface, the top block surface, because it touches the ground, right? These surfaces will be moving relatively with the ground. These surfaces is moving because sometimes you will have an object moving, but it will be still in a static friction, which is a case of a non-slipping motion, which we will discuss later. But now I would say that this friction is friction that you have when there is a relative motion between surfaces. Okay. Okay, enough with the theory, we'll jump into the question. Okay, I'll show you guys the okay, I have to stop to share the screen and show you guys the question. So this is the question. Okay. So yeah, the question is that a block of mass m, 2 kg, is pushed from rest up a slope of length d, which is 3 meter, by a horizontal force 40 Newton. Shown as this figure. The rough slope, so the slope is rough. They have the friction, the kinetic friction here, 0.2. And the moment that block leaves the slope, the force is removed and the block lands at a horizontal distance d from the vertical slope. show that the acceleration of the block when it is on the slope. Okay, so we'll find the acceleration with the Newton's law here. And then the next one is that sketch only the vertical component of the acceleration during the whole journey of the block. Okay, and then this one is just sketching the um, only sketching the acceleration, which is pretty easy, and then calculate the distance d. Okay, it's pretty. This question is pretty easy. I mean, for most of the students, it will be hard, but we'll discuss about this um, just right now. Wait. Okay. First, I'll just send this question to my uh, tablet. Wait a second. Wait. Mm, okay. So, okay, the block of mass m 2 kg is push. Okay, it's just push with the horizontal force. So even though this mass is moving with only in this direction, but the force given. So this is the external force that I'm saying. It's represented by our arrow. It's given by the problem. So okay, it's going horizontally, and um, this thing will move upwards, and that's it. And then it will go follow a parabolic motion afterwards, and that's it. Okay. So the first question is that we have to show that the acceleration is something. We have to show that the acceleration is at 0.02. We have to show them this. Okay, it's really simple. We just have to um, draw the free body diagram. So before that, I would like to give you a little bit of tips to do dynamics problem. It's very easy. One, just draw a free body diagram. Already, if you already draw a free body diagram here, okay, you will already get at least partial points. At least if you draw it correctly lah. Second, um, project two important axis. What do I mean by import? So you just have to project all of the forces to important axis, and then write down equations from each axis. Okay, yeah. So, and then the third one, of course, yeah, solve the equations, and that's it. That's the only thing that you need to do in free body diagram. Maybe you will have like the 1.5 steps if the problem is very hard. If the problem is very harsh on you, but they mostly very harsh on you, I guess, because PH1011 the module is very hard. They will give you some crazy looking problems when you have to find the mm, relations between acceleration, which is, yeah, which is there lah. The idea is there. If you find this kind of problems, um, you have to do this. But I will show you. Maybe if I find it, I'll show you some of the questions that require you to do this. But most of the time, for the regular basic dynamics problem, you just have to do just three steps, and you're done already. And then if you already do the first and the second one, and then you haven't actually solved the problems, you get partial points for only drawing up. Even if your drawing is sucks, uh, the the lecturer or the grader will see the effort, and most of the time, depending on your grader, they will give you some marks, which I don't know how much are. But yeah, you just try your best. So that's the three common basic rule to do a dynamics problem. So the first thing, you just draw the free body diagram here. So the free body diagram, it's drawing all of the forces here. One of the obvious forces that you have is weight. So I haven't write down weight in my possible forces because it's just as simple as weight. So I don't need to, I guess. Maybe if you want to write down its weight, it's just a number zero because it's very obvious that you'll have weight. But if you have something on a plate on top of a table, so if there's a system there like this, and then like these are, and there's a spring or whatever, but it's on top of the table, so you see your point of view is from top of the weight is pointing into the paper, so it doesn't matter if you draw it or not. But for this part, right, yeah, it's moving upward, so it's not a plane, it's not a tabletop. So yeah, obviously you have a weight, and most of the time you'll have weight. But if the question is specifically telling you that it's on top of a table, or your point of view is from up view, then you don't need to write a weight. You don't need to draw a weight. So yeah, as I told you earlier, um, create an angle not close to 45 degree, because this is a small angle, right? If you draw the angle like this, it will be very hard for you. Okay, so you have this weight, so this is theta, so obviously the small angle is theta, and then you have this force pointing this way, and then obviously I told you that there will always be a, normal forces, which is normal to the plane. So where's the plane here? The plane here, yeah, it's here. It's the plane that they're touching, the surface that they're touching. So it's perpendicular to the plane. There will be normal forces. Okay, what happens? I'll just draw it in different colors so that it's easier for you to see. This is the normal plane. And there's another force, which is the friction force, which they told you the kinetic friction only, not the static friction. So what they meant by doing this is that they assume that this condition already passed the static friction state. So they ignore the static friction. They ignore the static state of a friction. So they assume that it's moving already. It's just moved. Okay, and then I'll draw the static force Fk here, and I think that's all we have for this. Okay, so by only drawing this, you'll already get at least, wait, what? At least 1 or 2 points. Okay, sorry, my tablet is lagging. Okay, and the next thing is to project all of these forces. So into important axes. Yeah, that's the step I told you. What is important axis? The important axis here is the axis. So important axis is the axis that they're moving on. Axis on uh, axis on which the object is moving to or on. I don't know. So because they're moving on this direction, right? On the direction of the plane, you want to project all of the other forces that is not directly on on those axes into this moving axis, to the axis that the object is moving, and the axis that perpendicular to that axis. So the important axis is 2. So let's call this axis 1. Axis 2 is the axis that perpendicular to axis 1. And that's it. That's the important axis that I meant on the drawing. Okay, this one is important. Yeah. I'll give it a box here. Okay, I'll put it here. Wait, important axes. So the explanation of important axes will be on the other 2 pages after, which is very weird, but whatever. So if you want to understand this whole slides, you have to actually watch the peer tutoring video, because otherwise you you will not be able to read any words that I write, because my handwriting is very, okay, whatever, we don't talk about it. Okay, so I'll move this drawing, and we'll zoom a little bit more on this drawing. Okay, so we want to project all of those to this axis. So which means this F will have to project into this axis. Okay, and this W will also have to be projected into this axis. Okay, so the F. So where is the theta? Is it here or here? Obviously, it is here, because it's looking that the theta is the smaller angle, and this angle is obviously bigger than this, and this must be theta. So without the mathematical knowledge, only by your drawing, you can already tell that this is theta. And for the weight, if you want to project this weight to this line, right? It's obviously not theta, because it's very big. Theta here is very small. So where's the theta? So the theta is with the axis that is perpendicular. Okay, we found that this angle is smaller. That's why I told you to draw the theta is in a very sharp angle or very big angle, so that you can tell the difference without even understanding the math behind it. Okay, so okay, so the arrow is pointing here. So to project this F, you have F cos theta pointing upwards. I'll draw it on green. This one is F cos theta. Okay, the green is not very good looking here, because the background is like that, the color, but whatever. So the weight here, okay, the weight on this direction, it's W sine theta. So if we write down the equation on this direction, it's that sigma F. On the direction, let's say this direction is X, and this is Y, and this is X prime, and this is Y prime. The x prime will be what? The x prime will be m times a in the direction of x prime, sigma fx prime, which is it's f cos theta pointing positively to the pointing in direction of x prime, and then this projection of y is here, y sine theta, but it's moving, it's directing to the negative side of the x prime, so it's negative y sine theta negative fk, which is the friction force, equals to ma x prime. Why do we assume that the fk is pointing downwards? Because we can tell that this thing is moving upward. They already told us that this thing is moving uh, from rest up a slope. It's moving up. Okay, and this will be our first equation. And before we finish our first equation, we will plug in the formula for the canticle friction, which is, so it's f cos theta negative w sine theta equals to f, which is n mu k, equals to ma x prime, and we'll have to show our first question telling us to show that 8.72 is a x prime, and to the direction of the w of the y prime, sigma f y prime, it's gonna be 0. Why 0? Because this thing is not moving on this direction. It will always be stationary in this direction, or it will always be on the plane. It will always be moving with respect to the plane. It's just on the plane lah. It's just on top of the plane. It's not flying off like this. Yeah, it always touches. It just touches. Yeah. So that's why it's 0. It's gonna be n minus w cos theta. Why? Because w here, the theta is here, so it's w cos theta. And don't forget that we have f here. So we project this into this direction, which is sine theta, right? This is the theta. Minus f sine theta. Why it's minus? Because it's going downward here. It's like this, right? You project this like this, it's downward. And this one is also downward, but the end here is pointing upwards to this y prime. You just follow your own coordinates on the first time you determine it. So the n equals to w cos theta added by f sine theta. This is the equation 2. And then this, because this is equation 1, right? So you just plug in equation 2 to equation 1, the n, right? The normal force, so that you have f cos theta minus w sine theta minus n is w cos theta added by f sine theta times mu k equals to ma x prime. So the x prime equals to 1 over m f cos theta minus mu k sine theta added by, wait, it's not added, divided by w sine theta at minus q cos theta. Yeah, whatever. This is just math lah. This is just math. You just reformulate this. I just reformulate this to this form because I like this form better. And then we just plug in the value. So the m here is 2 kilogram. F equals to 40. The W is mg, right? Which is 2 times 9.8. So if there is no g given, you just assume that g is 9.8. Okay. I mean, usually on the first page they will tell you this. So on the like exam rules, they'll give you that, okay, if this problem is not specifically telling you what g is used in the question, you just assume that g is 9.8 meter per second squared. Okay, yeah. And then the theta is 30 degrees, so sine theta equals to half cos theta equals to this square root of 3 over 2. So I'll just plug this into my calculator first. So it's 1 over 2 times t times cos t negative. The mu is 0.2. Okay, so ax prime. I'll try to find x prime. Wait, 0.2 sine t minus t sine t divided by 0.2 cos 30. So it's 8.02349. So yeah, it's just 8.02, and it's correct. It's the same, right? Okay, that's our first question, which will lead us to the next question. The next question is just sketch the uh, y-axis acceleration. Okay, so this is AY and this is y acceleration versus time, is it? Wait, let me check. Versus time. Okay. So for a time from here to this point, from this point to this point, from this position to this position, the acceleration is constant, which is ax prime here. But on the y direction, on the vertical direction, you have to project this with theta here, which is ax prime sine theta, and it's positive, it's upwards throughout the motion here. Okay, but after this it will fall, right? And when it's falling, they told us that the force is not applied no more. Okay, the force is removed, right? After it leaves the slope, the force is removed. So take note of this. So it will only free falling like this. It will only free fall. And what happens when they're doing free fall? When it's free falling, the acceleration is 0.8, obviously. Free fall, yeah, it's just free falling. So the only force that affects you is the gravity force, the weight, which is the acceleration will be 0.8, but it's downward. So the acceleration will be this acceleration, ax prime. You projected this acceleration into y direction, so the theta is here. It's ax prime sine theta. So because the acceleration is like this, and this is theta, right? Obviously, and this is ax prime sine theta. So sine theta is sine 30. So 8.72 times sine 30 will be 4.36. So it's 4.36. It's going like this, right? Until it falls. When it falls, it suddenly the acceleration will be the gravity acceleration, which is 9.8. Sorry, yeah, maybe this graph is not in scale. It's going like this until it falls down, and it falls down. I mean, until it touches the ground. Until it touches the ground here. Until it touches the ground here. Yeah, there's no y acceleration because it just dropped. So it will go back to 0. So we just draw this. That's it. Okay. But you have to find the time here. Time 1 and time 2, so that the graph that you're showing is accurate. So you, because this is the time axis, you have to find t1 and you have to find t2. How to find t1 and how to find t2? To find t1, it's really easy. You are given a d here, right? They give you the d. What I mean by give you the d is the distance, yeah, distance. So because the initial velocity is 0, d equals to uh, y naught t plus half of a t squared. Y naught is 0 and a is ax prime, which is 8.02. So 2d over ax prime is t squared, which is t is only the square root of this. So it's square root of 2 times the small d is 3 meter times 3 over 8.02, which is the t here is 0.83. So t1 is 0.83, and t2 is the time that it takes for this block to fall onto the ground, right? Now, because at this point the mass m will already have acquired a velocity, you have to consider those velocity. How? So we just first have to find the velocity from the previous phenomenon. So the phenomenon here, we have two phenomena, which is the phenomena that takes this m up to the slope, and the second phenomena is the phenomena where this block is going on a parabolic motion. Okay, so from the first phenomena, we'll get the final condition of this block, which will be the initial condition for the second phenomena. Okay, so we just try to find the velocity. Yeah, the velocity equals to the phi naught added by a t. T is 0.93. Even we found it, and v equals to, because phi naught equals to 0, right? It's just 8.02 times 0.83, which is uh, 0.233. You say 0.23 is the velocity on the top of the slope, on this top of the slope, right? On this top of the slope, it has the velocity of 0.23. Okay, and then after that, we'll just do the 8.03 meter per second with the theta here is 30 degree because it's moving on the direction of the theta here, right? It's 30 degree, and it has the initial height of because this is d, right? D, and it's 3 meter, and this is 3 meter sine theta, 3 meter times sine 30, which is 3 times 30 is 1.5. So this is the second phenomenon. Okay, how to find the time? You just use the equations that I gave you before. So we just take this first thing as point x and y. So to use my equation, to use the equations that I told you about the parabolic motion, just use the initial point as the x 0.0 coordinate. Okay, and then you'll transform later depending on the question. You'll transform the points later on depending on the questions. But so initial points always use as you don't have to But if you don't use that, you cannot use my equation. You have to really understand the basics. For this, uh, you'll use my, if you want to use my equations, the point here is point, so on the x direction, it will be moved as much as d, but it will move minus 1.5 meter vertically. So this point have a point of d point minus 1.5 meter, and we have to find d letter, but we need to find t2 first for the graph, and we also use t2 for the d lah, and we'll just straight goes on to it with minus one with the equation I gave you before for the parabolic motion. Here y equals to phi naught sine theta, y equals to phi naught sine theta minus half of gt squared and times c. Sorry, y here is minus 1.5. The phi naught is 8.73 sine 30 times t minus half of g is 9.8 times t squared. And you just plug this in into the calculator, because in the calculator, on your scientific calculator, you can solve this kind of problem. If you don't have a scientific calculator, and you have a graphic calculator, I don't know how to use because I don't have it. So you have to learn how to use your calculator. And I guess just find it on YouTube to use your calculator. So for my Casio FX99EX class with scientific calculator, I just use the solve the polynomial equation function, and it's polynomial to the power of 2. So the t that I get two t's here. I get because it's easily um, a quadratic equation. So you'll get two values, 1.156 t equals to minus 0.26. Okay, and yeah, you'll use this. Obviously, you don't have a time of negative. What this negative time means is means that because we want to find the y negative 1.5, right? For this graph, it reached negative 1.5 twice. It's not only here, but it's on the back of the time here, which we don't actually have, right? Because previously it's just another motion. So yeah, it's imaginary, and the time is 1.156. But the time is starting from here. So if you want to write t2, right, you still have to write 1.156 added by 0.83, because at before previously you reach this point at 0.83, and 1.156 is the time that takes this until this. So from this point to this point, it's just 0.83 added by 1.156. 0.83 added by 1.156 will be, let's just say that this is, okay, it's 1.9897 seconds. And that's it. That's for the graph. And because we have the time that takes here from here, and then for the horizontal for the horizontal axis, it's moving with the constant velocity. Yeah, so the d here, d just equals to vx, which is v cos theta times the times, which is this, the v cos theta is 8.03 cos 30 in times the t is 1.156. It really is right, 0.23. The v here it's, oh, the v here is 0.23, not 8.03. 0, sorry guys, 0.23. So this one have to change, time will have to change also. 7.23. Crap. So sorry. Really, sir? Yeah, it's 0.23. That's why I find it weird. Why the velocity is bigger than the, okay. I'll just try to find the t. Sorry. So uh, it's 1.034 and 0.296, which, yeah, this one, these things still mean the same. And 0.34 would be 1.86, 0.23 cos 30. Yeah, the d is 0.47. Yeah, and we find the answer for C. This is for B. This is for A. Yeah, I think that's enough for today. So this will cover the materials for quiz 1, except for the momentum and energy. We'll talk about the momentum and energy later on. Thank you.